Right, here we're going to be looking at the four main spheres of our Earth and seeing how they help our unique planet, our third rock from the sun, support life. And these spheres interact with each other, but we're going to look at them in isolation and then start doing a little bit of connections here and there to get a better understanding of them. So our Earth is made up of four distinct areas known as the atmosphere, the biosphere, the hydrosphere, and the lithosphere. And so you can see here with these great pictures that they're trying to show you the main areas or features of those spheres. And so let's get into those, and some of these words may be new to you. So get your definition pencil ready to write them down. All right, the four spheres that we know, the biosphere, we're going to start with the biosphere, is all the living things. Remember, the prefix bio means living. Okay, and so it's all the living things on our sphere. It's got a massive variation. It goes from the smallest microbe to the largest animal that we have. Now, the smallest microbe, of course, are bacteria, etc. Here is a picture of fungi, which is still a microscopic organism, and we have an extremely large organism here, which is a humpback whale. But the biggest organism we have is a blue whale. And so all the animals that we have, all the plants, all the fungi, all that sort of stuff, everything that's living is included in the biosphere. Now, these organisms need the other three spheres to survive. Okay, so this is where we get a connection between the biosphere and the lithosphere, because the lithosphere has minerals, etc., that plants need to survive and, of course, make food. And we animals need the plants. So the lithosphere is needed for that. It's also needed to help home lots of animals. A lot of animals live in burrows, they live in the soil, etc. They get protection from different geological structures, etc. So all those sort of things help animals survive. Of course, they need water to survive, and we all need air to survive. So our biosphere needs that. And so we've got a clownfish and sea anemone. We've got a cleaner wrasse. Pretty cool organism there. The relationship between the cleaner wrasse and a fish. Jackals, and I've left the F there, but I think it's the jackals are following a lion. And this one's pretty cool. This is a Demodex mite, and these mites live in 80% of people in their near their eyelashes, and you may have some. They're a beautiful pet to have, not really, but these are little mites that live on. So they're living things. We have trypanosomes, which is a single-cell organism that causes a disease known as African sleeping sickness. And then, of course, we have the head of a tapeworm. So all of these are examples of the biosphere. And you may remember stuff when you did food webs and relationships that you encountered these as well. Well, what about the lithosphere? Well, lithos means rock. And so it is all to do with the crust, the geosphere, but it's all the regions of the Earth from the outer crust to the inner core. And we can see here from both of these graphics some key features of these particular regions of the lithosphere. Now, this one does have the atmosphere in there, so we're just going to ignore that temporarily, right? But if we have a look, we have an inner core, and that inner core is a solid ball of iron and nickel, and it's extremely hot. Then we have the outer core, right? That outer core is also iron and nickel, but it's liquid now. It's not a solid like the inner core, and it's a little bit cooler. Then when we go to the mantle is the largest layer of the Earth, and it is cooler again. Okay, and it's made up of a lot of silicon type minerals. And then we have the crust, which is where we live and where all organisms tend to live. We get no organisms living down here, but all the organisms are living on the crust, which is the coolest spot. It can have a large variation in terms of its temperature, and it's composed of, like we said before, igneous, sedimentary, metamorphic rocks, etc. So that is the lithosphere of the Earth. And we're going to look at that and how that relates to other processes, whether they be from earthquakes to volcanoes to rock making, etc. Then we have the hydrosphere. Now, the hydrosphere is the sum of all the water on the Earth. Most people think it's just oceans. The hydrosphere is oceans and lakes. But there's other water as well. We get frost, so we're getting water that's in the air condensing from a vapor. So that vapor water is still part of the hydrosphere. Even though we talk it is a part of the atmosphere, it's still water, and that water can condense to form liquid and also make solids. And this is so cool, this picture, because if you check this out, you can see the crystals. Look at them. You can see these crystals of water. Beautiful. These geometric shapes, right? Okay, and then of course we have a glacier. So this glacier is a massive body of water. We have icebergs, so rivers, lots of things. So don't forget our good old vapor and fog, etc. that is part of the hydrosphere as well. And then of course we have our atmosphere as our last sphere. Now our atmosphere extends from the surface of the Earth, right, which is known as the troposphere, all the way out. So we've got different layers depending upon lots of different characteristics, so the air temperature, etc., and what they have in there and the distance away. So we have the troposphere, which is the one that we see and live in. It is the one that mostly has all the weather, all the clouds, all existing in the troposphere. Then we have an ozone layer up here, and that is at the beginning of the stratosphere. The ozone layer, of course, is very important because it stops a lot of the UV light coming from the sun. Then after the stratosphere, we have the mesosphere. Then we have the thermosphere, and then the exosphere, which is pretty much out in space. Okay, and so that's the layers of the atmosphere. In the troposphere, which is where we breathe, we have this composition of air. Most of the air is made up of 78% nitrogen. Okay, we have 21% oxygen, and then we have a very small percentage of other gases. You may have watched the other videos in the chemistry course when we looked at nitrogen, but we did some liquid nitrogen. So here's a quick video of liquid nitrogen, and I tend to use in classes and in workshops and shows to talk about the composition of the air. So I fill up a balloon and then talk about that the oxygen is only a very small percentage, 21, and most of it is nitrogen as a gas. And of course we use that nitrogen that I've got, the liquid nitrogen, to then cool down the balloon, and we talk a lot about lots of other things from condensation, etc., etc. So pretty cool. So if you haven't seen that sort of stuff in the chemistry course, go check it out now. So gravity holds the atmospheric gases to the Earth, okay, and so the body has to be large enough to contain an atmosphere, and that's why the moon has no atmosphere. The gravity is not strong enough to hold on to gases, and that's why Mars's atmosphere is so thin, because the gravity on Mars is less than Earth, and so it doesn't hold as much gases to the surface of the planet. And we've already mentioned a bit about the nitrogen. So hopefully now you know the four main spheres of the Earth, you know their main sort of features and characteristics, and that the spheres can sort of interlink with each other, and organisms need a combination of all the spheres in order to survive. So of course we're going to explore aspects of these spheres in more detail in the videos to come, and so I'll see you in those ones. And as always, make sure you revise your notes, do great notes in terms of the colors, the organizations, mind mapping relationships between the concepts, and you look at them and revise them in an active way. So I'll see you in the next video.